Hi, good day everyone. Here are some examples on conservation of momentum and energy collisions. For example, number one. For letter A, what is the magnitude of the momentum of a 10,000 kilogram truck whose speed is 12.0 meters per second? So to calculate the magnitude of the momentum, we have this given. The mass of the truck, take note, is equal to 10,000 kilograms, while the speed of the truck, denoted by Vt, is equal to 12 meters per second. So the magnitude of the momentum is just equal to this. The magnitude of the momentum is equal to the mass of the truck times the speed of this 10,000 kilogram truck. So this is basically equal to 10,000 kilogram times 12.0 meters per second. So therefore, the magnitude of the momentum is equal to 1.20 times 10 to the 5 kilograms meter per second. So this will be the magnitude of the momentum of a 10,000 kilogram truck whose speed is 12.0 meters per second. Now, how about for letter B? What speed would a 2,000 kilogram SUV have to attain in order to have the same momentum with this 10,000 kilogram truck and the same kinetic energy? So for letter B, we need to solve for the Vs. Okay, the speed of this 2,000 kilogram SUV we're given is the mass of the SUV is equal to 2,000 kilograms, and the momentum of this SUV must be equal to the momentum of this 10,000 kilogram truck, which we know this one in our previous calculation. This is equal to 1.20 times 10 to the 5 kilograms meter per second. The momentum of this SUV, the magnitude of this momentum of SUV is equal to PS, which is equal to the mass of this SUV times the speed of this SUV. Which is from here, we can solve for the VS, which is equal to PS over MS. And we know PS it is equal to 1.20 times 10 to the 5 kilograms meter per second over the mass of this SUV is 2,000 kilograms. You can set the kilograms, therefore the VS is equal to 1.20 times 10 to the 5 divided by 2,000, that will be equal to 60. The unit is meter per second. For letter B, double I, for letter B double I, what will be the Vs at same kinetic energy? So it means na the kinetic energy of the truck must be equal to the kinetic energy of this SUV. T is truck, S is for SUV. So what will be the speed of this SUV in order to attain same kinetic energy with this 10,000 kilogram truck? We know the expression of kinetic energy. Take note, kinetic energy is equal to 1/2 mv squared. So from this equation, you will get kinetic energy of the truck is equal to 1/2 times mass of the truck times velocity of the truck, quantity squared. This is equal to 1/2 the kinetic energy of the SUV, mass of the SUV, velocity, speed of the SUV, quantity squared. And we know mass of the truck is 10,000 kilograms, mass of the SUV is 2,000 kilograms. Solving for what? You need to solve for Vs. Okay, Vs here is equal to square root of mass of truck over mass of the SUV times the velocity of or the speed of the truck. So this is equal to square root of mass of truck is 10,000 kilograms over the mass of this SUV is 2,000 kilograms times the speed of the truck, which is equal to 12.0 meters per second. So the speed of the SUV is equal to 27 meters per second. So you need a speed of 27 meters per second in order to attain the same kinetic energy with this 10,000 kilogram truck. Okay, example number 2. A baseball has mass 0.145 kilograms. If the velocity of a pitch ball has a magnitude of 45 meters per second and the batted ball's velocity is 55 meters per second in the opposite direction, find the magnitude of the change in momentum of the ball and of the impulse applied to it by the bat. If the ball remains in contact with the bat for 2 milliseconds, find the magnitude of the average force applied by the bat. So, solution for letter A. For letter A, we need to solve for the magnitude of the change in momentum, and we also need to solve for the magnitude of the impulse. Okay, so what is now the magnitude of the impulse and what is now the magnitude of the change in momentum? Change in momentum, this is just equal to the momentum final minus momentum initial, and we know momentum is just mass times velocity, so we have mass times velocity final minus mass times velocity initial. So basically, change in momentum is just equal to mass Vf minus Vi. We know M, given M, the mass of the baseball is around 0.145 kilograms. We also know Vi, this is the initial velocity of the baseball, and this is equal to 45 meters per second. How about the final velocity? After it hits the bat, the velocity now becomes 55 meters per second. But take note, the direction is opposite. So if your Vi is positive 45, then your Vf is negative 55.0 meters per second. Again, why is it that there is negative? Because the direction of your baseball is now in the opposite direction. If our initial velocity is positive 45, meaning it is going to the right, then the final velocity is in the opposite direction, meaning your Vf is the direction of your of motion is going to the left. So therefore, the change in momentum is equal to mass times Vf minus Vi. Mass is equal to 0.145 kilograms multiplied by the Vf, which is equal to negative 55 meters per second, minus the Vi, it is equal to 45 meters per second. So the change in momentum now is equal to negative 14.5 kilograms meter per second. But the problem is we need to find only the magnitude of the change in momentum. Magnitude meaning we will neglect the direction, so that the magnitude of the change in momentum is just equal to this. The magnitude of the change in momentum is just equal to, we will neglect the negative sign, so this is now equal to 14.5 kilograms meter per second. How about the impulse? The magnitude of the impulse, this is just equal to the magnitude of the change in momentum, and this is equal to 14.5 kilograms meter per second. So this is now the magnitude of the change in momentum, and this is the magnitude of the impulse. For letter B, at delta t equals 2 milliseconds. This is around 2 times 10 to the minus 3 seconds. What will be the average force applied? So what will be the force average. Using the equation for impulse J, okay, is equal to the force, average force, times the collision time, delta T. From this one, we can actually solve for the average force, which is equal to the momentum, the impulse, sorry, over the collision time. And we're going to solve for the magnitude of the average force. So the magnitude of the average force is just equal to the magnitude of the impulse over the delta T or the collision time. So therefore, this is equal to the F average is equal to the impulse, which is equal to 14.5 kilograms, 14.5 kilograms meter per second, divided by the collision time, delta T, which is equal to 2 times 10 to the minus 3 seconds. So therefore, force is equal to 14.5 divided by 2 times 10 to the minus 3. This is equal to 7,250. The unit is kilogram meter per second square, or that is equal to Newton. So the average force is equal to 7,250 Newton. Okay, another example. Example number 3. A golf ball of mass 0.045 kilograms is moving in the positive x direction with speed of 9.0 meters per second. And a baseball of mass 0.145 kilograms is moving to the y or to the negative y direction with a speed of 7.0 meters per second. Question is, what is the total momentum of the system consisting of the two balls? So, solution, we have this, the total momentum of the system consisting of the two balls is you just have to add these two momentums. The momentum of this golf ball, I call that one as PG, plus the momentum of the baseball. Take note, momentum is a vector, so you need to add this. You need to consider the direction in adding these two quantities. We also know that momentum is equal to mass times velocity, so therefore the momentum of golf ball is, we have mass of the golf ball times the velocity of the golf ball plus the mass of the baseball. The momentum of the baseball is, we have mass of the baseball times the velocity of the baseball. Given, these are the given, mass of the golf ball is equal to 0.045 kilograms, while the mass of the baseball is equal to 0.145 kilograms. Now, how about the velocity of the golf ball? The velocity of the golf ball, the direction of the golf ball is moving, it is moving in the direction positive x direction. So therefore, the velocity of the golf ball, it has a speed, or the magnitude is 9.0 meters per second, and the direction is to the positive x direction, and we denote positive x direction as positive I hat. Okay, so therefore the direction of our VG is I hat. Take note, I hat is positive x direction. Okay, I hat is positive to the positive x direction. So this is now my VG. The VB, the velocity of the baseball, it has a speed of 7.0 meters per second, and the direction is going to the negative y direction. Negative y direction means that the unit vector, you will use the unit vector of negative j hat. Okay, so the negative y means negative j hat, so we have negative j hat. So therefore, the total momentum, the P total, this is equal to mg times vg, so we have 0.045 kilograms times the velocity of the golf ball, that is equal to 9.0 meters per second I hat, plus the momentum of the baseball, we have mass 0.145 kilograms times the velocity of the baseball, that is equal to negative 7.0 meters per second j hat. And if you multiply that one, these two, you will get the total momentum is equal to 0.41 kilogram meters per second I hat minus 1.02 kilograms meter per second j hat. So it has two components, the components along x and the components along y. To solve for the magnitude of this momentum, you will use this. This is equal to the square root of the component x quantity square 0.41 kilograms meter per second quantity square plus the component along y, which is 1.02 kilograms meter per second quantity square. So the total momentum magnitude is equal to 1.10 kilogram meter per second. So this is the magnitude of our total momentum, and the direction, we can use the tangent inverse of the y component. The y component is negative 1.02 kilograms meter per second, and the x component is 0.41 kilograms meter per second. So this is equal to 68 negative 68 degrees. Negative 68 degrees can be written also as 68 degrees south of east. So this is now the direction of the total momentum, and this is now the magnitude. This is the magnitude, and this is the direction of the total momentum. So therefore, the total momentum of the system, the total momentum of the system is equal to this. The total momentum of the system is equal to 1.10. The magnitude is 1.10 kilograms meter per second, and the direction is 68 degrees south of east.